Previously on What is Probability? So last time we talked about board games and what happens if you're on this space and want to get to this space. Well, in order to do that, you need to roll 2 dice. 2 dice give us a much larger sample space than just 1 die. In this case, we've got 36 different possibilities in my sample space. And we want to go 4 spaces. 4 spaces show up 3 times in my sample space. So that means 3 out of the 36 possibilities, which means about 8.3% chance that you will land at that distance. We then talked about other probabilities, dealing with board games and rolling dice. That was to get us ready for what happens when we draw 2 different cards, and what's the probability that we draw 2 diamonds. We had to discuss with replacement. With replacement means that when we pull a card, we actually put it back. So our second card could be our first card. We pull the card, we put it back, we shuffle it up, and then we draw a second card. So because we could get that first card twice, we have 13 out of 52 both times, which means a 6.25% chance that we get a probability of 2 diamonds. Then we talked about what is the probability we draw 2 diamonds, but in this case without replacement. This means drawing a card, looking at it, and then drawing a second card without replacement, without shuffling. This means that we start with the 13 out of 52, but in our second draw, we only have 12 out of 51. Without replacement then lowers our probability. What is probability? Episode 3, Summaries. Illustrated and narrated by Izzo. So today we're going to talk about summaries, particularly two-way tables. Two-way tables are a great way to take a whole big sample space and boil it down into something that is more usable. This is an example of a two-way table. So we've got diamonds versus not diamonds, and then we've got queen, crazy eights, and other ranks. And I've organized all of the 52 cards into their allotted slots. The first thing we do with a two-way table, in order to use it, is we need to get some totals in there. So I start with the totals of diamonds, which are 13, and the totals of not diamonds, which is 39. The total number of queens is 4, the total number of crazy eights is 4, and the total number of other ranks is 44. Notice, if I take the total column, the 4, 4, and 44, and add those up, I should get the same number of cards as if I take the total number of row, the 13 and the 39. I should get 52 in each case. Using a two-way table, I don't have to draw out all 52 cards, which is a whole lot better, particularly if you're trying to calculate probabilities on paper. So what is the probability we draw a queen and a diamond? Well, a queen and a diamond would be right there, that one card that is both a queen and a diamond. So 1 out of the full 52 cards. That is how we use a two-way table. However, although the two-way table makes something simpler, it makes other things more complicated. What is the probability we draw a queen or a diamond? In this case, we want the queens. There are a total of 4 queens. We want the diamonds. There are a total of 13 diamonds. And most people would just try and take the 13 and add it to the 4. But if we do that, we've double counted the Queen of Diamonds. We counted it in the diamonds, and we counted it for the queens. This is where things get tricky. So, what we do is we take the 4 out of 52 queens, we add it to the 13 out of 52 diamonds, and then we subtract 1 out of 52. That way we're not double counting the Queen of Diamonds. So as you can see, it gets a little bit more complicated. Notice the thing that normally makes it more complicated is our conditions. For conditions, what is the probability we draw a queen given it is a diamond? This actually turns out to be a whole lot easier. We've got 1 Queen of Diamonds and only 13 diamonds. The rest of the table doesn't matter at all because we are given it is a diamond. 1 out of 13, and we are done. This is extremely helpful when we're doing card games and when we're trying to find probabilities of populations like that. However, two-way tables are not the only way that we can simplify populations. Populations are a large group of things. It could be a group of cards, it could be a group of people, it could be a group of spots on a die. Population regularly needs to be simplified. So, what we do is sometimes we summarize a population, and we do that by calculating parameters. This is where your grade comes from. So let's take your quiz scores. Say these are your quiz scores. We've got a nice population. This is the population of your quiz scores, and that would be our sample space. So some weeks you do pretty well, some weeks not so well. These are your quiz scores. These are all the quiz scores that exist. So this would be the population of your quiz scores, your sample space. Now, what is the probability we look at a random week and get a 3%? That would be 1 out of 10. What is the probability we look at random and get a 98%? That would also be 1 out of 10. Notice, each of your quiz scores have equal probability, except for some. If we take a look at 85, you actually have 85 twice. So some probabilities do get higher. These probabilities are nice, but this is not where your grade comes from. The problem is with all of these scores, we want to find a way to take these and somehow merge them into something that is indicative of your grade as a whole. So the first thing that we do is we take your quiz scores and we line them up. So the smallest goes on one side, the largest goes on the other. We have organized them from least to greatest. Once we've organized them from least to greatest, we can do some math on them. We can find your average, meaning add them all up and then divide by the number of numbers. That gets us our mean, or 68.7. Sometimes we call it the mean, sometimes we call it the average, just depends on what we're doing. Sometimes what I personally would rather do is look and see what happens in the middle. In the middle, we've got about a 78.5. That's called the median. The median is midway, so half of the scores fall on one side, half your scores fall on the other side. Other people prefer to look at the mode, or what happens the most. Most of the time, you either get an 85 or a 76. At least that's what repeats. So mode is the most popular. And then we have the range. Mean, median, mode, and range are frequently what we discuss when we're talking about very basic parameters. In this case, when we're talking about quiz scores, I don't care about randomly drawing one of your quiz scores. I want to know what the population is doing as a whole. I want to combine all of your 10 scores into a number that actually tells me what is happening in your life in this class at this time. So, in order to do this, we talk about parameters, mean, median, mode, and range. Sometimes I want to know what your average is. Most of the time, that's what you're looking at. I like looking at what's in the middle. Other people like looking at what's most likely to happen. And then there's the range. The range tells us how far spread you are, how large that gap is from the lowest to the highest. In this case, it's a really big gap. Now, the reason why I like the median. In the median, we've got half your scores on one end, half your scores on the other end. So I know about half the time you'll do better than a 78.5. Half the time you'll do worse. This tells me a lot about what's happening. See, the problem with the average is the average takes that 3 and that 32, your really, really bad days, and it gives it a lot of weight. It gives it as much weight as the others, and it drags down your average. Notice, those are the only two scores that are below your average. You will do better than 68.7 80% of the time. However, because you did so poorly on those two quizzes, your average is dragged down. The median is better at telling us where you are most likely to fall. Because the median is better for this, that is what a lot of scientists tend to use. Scientists prefer the median, particularly depending on how spread out the population or the sample is. Your population of quiz scores is really spread out. It's going from 3 all the way to 98. That's a very large span, from 3 to 98. They call this the minimum and the maximum. The median is the middle. Sometimes, just for fun, they decide to break it down into quartiles or quarters. So quartile 1 would be a 70%, and then the third quarter would be about 85%. Notice the second quarter or second quartile would be our median. This is better because it gives us a 5-number summary. It tells me what you're capable of doing. You're capable of either a 3 or a 98. But for the most part, you don't do that. These are also parameters. Parameters are any measurement I have on a population. If I measure the population, if I try and take that full population and boil it down to one number or a set of numbers, that is called a parameter. I do this because of this. Look at the interquartile range. The interquartile range is only 15 points. Half the time, you are between a 70 and an 85. This parameter is a whole lot more accurate than the full range, which is from 3 to 98%. So depending on your numbers and depending on what you want to do with your population, some parameters are more helpful than other parameters. If we go back, we saw the average and the median. I prefer the median. The median is more indicative of what you do. If we look at the range from the minimum to the maximum, or the interquartile range is more indicative of what you do. So, be very careful. Some parameters, some measurements on the population are better than others. Because the 5-number summary is such a good measurement of a population, many scientists like to put a graph to this. So what they do is they mark the minimum and then they mark the maximum with dots. Then what they do is they mark the quartiles with lines and the median with a line. They then attach to make a box. In this box is half of your grades. The middle half of your grades, where you're most likely to fall, is in that box. That is approximately where you are, where you live. However, you can go all the way down to 3 or all the way up to 98, depending on the day. This box and whisker plot then is a beautiful visual representation of all of those numbers. So instead of looking at just a list of quiz scores, you can look at a box and whisker plot and figure out what it looks like, what your grade looks like. It's called a box and whisker plot, of course, because we've got a box with whiskers. Yes, mathematicians are that inventive. Box and whisker plot. Unfortunately, normally we talk about the quiz scores, but we also talk about your test scores, and we talk about your homework scores. This is the true population. And normally we don't talk about the median. We don't talk about the box and whisker plot. When we're calculating your actual grade, we have to take all of these scores and then somehow merge them into one number that actually identifies how well you're doing in a class. This is a very large population of numbers that represent very, very different things. We need to take all of those numbers, all of those different things, and somehow summarize them into just one single number to go on your report card. And that is what we are going to be talking about next time. The